Hey everybody, Mr. Tannen here. One of our top scholars asked us to go over number 23 and 24 from the 2018 practice test that was posted on AP Classroom. 23 was an interesting one because when I first looked at it, okay, acceleration, I was thinking second derivative. But actually, the acceleration of a particle is given by this function. At what value is the particle's velocity decreasing most rapidly? Well, let's think about where is the particle's velocity decreasing most rapidly? It would be decreasing most rapidly at when acceleration is the least, or we just want to find the minimum of acceleration. So this is a calculator active question. We're only looking on the interval 0 to 8. If you're on the TI Inspire here, what we could do is, well, check first. I'm in radians. You can see up there. I could just put my function. I'll just use x, which is the standard input. X minus 8 times trig sine of x. If I hit enter, you can see where is it decreasing most rapidly. It looks like the minimum between 0 and 8, the minimum is going to be down here. So I could already guess it's going to be B because it's between 1 and 2. But if you really want to find it, I could do menu, analyze graph, find the minimum, click to the left, click to the right, yeah, 1.42, so I got my answer. Similar process on the 84 if that's what you're working with. Oh, I already got it in there. Graph it. I might want to do zoom fit. What's that? Zoom fit. Let's see if that looks any better. Okay, nice. See what the window is. Well, again, right away you could maybe think it's going to be 1.42 because that's the only answer that looks reasonable. Second calc, if you want to find the minimum, it's the third option. You just go to the left with the arrows, enter, right, enter, and it'll say guess. You could just go near it and then press enter. You got the same answer. Okay, not bad on that one. Number 27, let's take a look at this one. Selected values of the increasing function h and its derivative h prime are shown in the table above. If g is a differentiable function such that h of g of x equals x for all x, what is the value of g prime of 7? Oh wow, interesting way they presented it, because this is essentially telling us what? They're inverses. Because h, whatever g does, h is undoing it since it just leaves you with x. So there's a few ways to do it. There's the more formal way, or there's the more casual way. Well, g prime of 7, as you can see, the inverse, because h of 3 is 7, and since they're inverses, that means g of 7 is 3. So I think we're going to compare g prime of 7 to h prime of 3. H prime of 3 is 5, so this would be 1/5. We also have the more formal way of doing this, which is that if they're inverses, we could find g prime of 7 by doing 1 over h prime of g of 7, which is essentially saying, well, go backwards. So g of 7, since h of 3 is 7, when g is its inverse, g of 7 is 3. So we're just looking for the reciprocal of h prime of 3. Well, h prime of 3 is right here in the chart, 5, so it'll be 1/5. Hope this helps. 2 quick ones there. both calculator active, so you would have 3 minutes each. Even doing it on both calculators when I didn't even have to find the minimum, you can see that we ended up with a answer in less than the given time, which would have been even quicker if I just used my one calculator and maybe didn't even find the minimum, just saw the reasonable answer. This one, you know, it's not going to be negative because there's no negative primes given, so we've already got a 1 out of 3 chance. You probably know it's the reciprocal of one of the derivatives given, so you probably already have a 1 out of 2 chance. Turns out it was C. Have a great day. Hope this helped for those of you that were curious about these problems. Tanning out.